Perfect. Right on the money at 5:30. Okay. Well, I assume we're all here then. I see a bunch of people watching. So I'm going to go ahead and get started. My name is Andrew. I am an instructor here at DSU. I've probably met many of you who are listening now already, but if I haven't, great to see you. Great to have you here. So we're going to be talking today just kind of about introductory Linux security concepts. I have this geared sort of at a beginner level. So if you're already a Linux wizard, this may be a little bit boring to you, but you can help your friends. Or if you're entirely new to Linux, hopefully this gives you some new things to explore.
Smaller mouse pad?
I thought I heard somebody. Or maybe they were just not muted. So as we're going through this, if you want to open up your browser and go to questions.defsec.club, you can type questions in there, and I think Shane will relay them via voice chat to me. So I would say if you have a question that you would like to ask yourself, feel free to unmute your mic and ask it. I'm fine with being interrupted. Please feel free. Otherwise, just keep your mic muted and ask your questions there. Apparently, you should also go to attendance.defsec.club, keep track of who's attending, and yeah, that's good to know. So what we're going to learn today is a combination of methods for hacking Linux machines. So we're going to kind of think like an attacker and look at how an attacker approaches a Linux system. Also talk about persistence mechanisms. So once an attacker is on a system, what can they do to stay there? And then most importantly for you all, tricks for finding those bad things, right? So how can you detect these things quickly and efficiently? This is not going to be an exhaustive list, right? There's tons of methods and persistence techniques that I'm not going to mention here. And there are also ways to hide the things that I'm going to talk about here that we may not cover. So this is not a be-all, end-all, but I think it's a good jumping off point for beginners and a good place to start. So my only assumptions are that you have some basic Linux understanding. Maybe you are somewhat comfortable on the command line. You can move around between directories. You're familiar with what a user and a group is. Maybe you know what Linux file permissions look like, kind of at that level, but you don't have a ton of experience yet. That's what this is geared towards. So we're going to talk about the following things. I have 8 things listed here, but sort of 10 because 2 of them are doubled, right? So we're going to talk about SSH keys, set user ID binaries, which you'll hear some people call SUID binaries. We're going to talk about file ownership and permissions. We'll talk about cron jobs. We'll talk about services, user accounts and passwords. We'll talk about firewalling just a little bit, and then we'll discuss some tricks with logs. So through all of this, if you get nothing else out of this slide deck, I think this is a helpful tip. So quite often when people are trying to defend a system, they will approach it from a standpoint of, I need to understand what bad things look like so that I can detect them, right? I need to have some signature either in my mind or in my code for what is evil, and I'm going to go find that evil and kick it out. And that tends to be a bad way to approach security because the attackers are constantly changing and evolving and using polymorphic code and doing all kinds of things to make their code look different every time so that it's hard for you to detect, right? So it's kind of a game of whack-a-mole at that point that you're going to be perpetually behind on. So a better way to approach security, in my opinion, is to first try to understand what things are good and what things should be on the system and what a default install with no bad things on it looks like, right? Because if you understand what the system should look like, then when you see something that's bad or different, it's going to stand out, right? You're going to be able to diff those two things in your mind and hopefully have an easier time detecting evil when it happens. So my motto, at least when I've been defending systems, is no good, find evil, right? If you can understand what the system should look like, it's going to be a lot easier for you to detect what is not right there. Okay, so let's talk about SSH and SSH keys first. SSH stands for Secure Shell, and that is a protocol for administering computers remotely. Essentially, it's a cryptographic network protocol where you log in and you get shell access. I'm actually logged into this machine with SSH here. In case you've never seen that before, I just type SSH some username at some machine in order to connect, and check it out. I didn't have to type in my password. I have now root shell access to this machine without having to type a password. And the way that I accomplished that is I configured a key pair with my private key on my local machine and my public key on the remote machine, such that the private key that I possess on my local machine here gives me access to this. It authenticates me to this system. So the way that this works is within your home folder here, right? I'm in my root home folder. I have a folder called .ssh. By default, folders with dots are hidden, right? If I run ls, I don't see anything with a dot in front of it. But if I use the A flag to ls, now I can see all of those other things. So I've got this folder here called SSH. This is my user configuration files for SSH, so things that affect only this account. And within that, you'll notice that I have a file called authorized keys. And then I have two others called IDRSA and IDRSA.pub. This here, IDRSA, is the default name for a key, but that can be something different, right? So often you'll see IDRSA, but it might be called dog. I don't know, it might be called something random. So what do we have? IDRSA is my private key. IDRSA pub is my public key, and it is a derivative product of this private key, right? So this is my key pair together. If I put this public key in the authorized keys file on a remote machine, I will be able to log into that machine using just this IDRSA file, this private key, right? So if my user account has a .ssh folder which contains this authorized keys file, that's going to give me access. So the way that I was able to access this machine remotely is if I look in the SSH authorized keys file, you'll see I have a public key for Andrew at desktop. And this isn't private information, right? This is a public key file. I could post this all over the internet, and unless you have cracked RSA, good luck finding the private key. So one of the first things that I would do if I was a defender trying to protect a Linux machine is I want to make sure that there are no authorized keys files on the file system that could be used for somebody else to log in. So the find command is fantastic for this, and the syntax for find is arduous at best. So we'll say find / and then I'm just going to say -name authorized keys. And it might be worth being aware that sometimes it's also called authorized keys 2, I believe, but this should find just about anything. And because this is also going to generate some errors, I'm going to say write all of the standard error messages to dev null, throw them all in the trash. So I'm just going to look through my file system here and see if I can find any files called authorized keys. And if I find some, I'm going to check whether they should be there or not. So we'll give that just a moment to run. There we go, there's another one. So in the home folder for the defsec user, there's also a .ssh with an authorized keys. And be aware, these are not the only two folders where those might exist. Any folder that is a user's home folder might have it. So for instance, if we look in the etc password file, the www data user, which runs the web server, their home is var www. So if somebody was to hack this user account, they could put a .ssh folder in there and then drop SSH keys, right? So just checking all over your system for files called authorized keys is a good idea. So to fix this, we're going to do a couple of things. First, I'm going to open up the etc ssh sshd config file. So within etc ssh, we have a couple of different configuration files. This is the one that I'm interested in, the server config. Whoops, let's do this. And there is an option in here for public key authentication. Where is it? I probably scrolled past it 3 times. Okay, I'm going to do Control W, find it, public key. Is it just called pub key? Maybe my slide is wrong there. There we go. So the default is to allow pub key authentication. That's an error. I'll fix that on the slide. It should just be called pub key. If you want to disable that, you should uncomment this line and put no there. I'm not going to save this because I am logged into my server with a public key right now, and I don't want to lock myself out, but that is useful. There are a ton of other important settings in here. I'll let you look through them. So, assuming that we saved that file, you also need to restart the SSH service for that to take effect. Depending on what type of machine you're on, I don't know, you might say like service SSH restart, or you might say something like systemctl restart SSH, or SSHD works too. So whatever your system requires for restarting the service. I'll try and pause after each slide in case there are any questions. Go for it. We are just scratching the surface here, right? There's a million more things to learn there. So, set user ID binaries. When we look at a file's permissions, like let's look at bin bash. Quick primer. File permissions are broken up into, well, I guess 4 parts. This first character here says what type of file it is. So maybe it's a regular file, maybe it's a directory, maybe it's a link. And then we have 3 triads, 3 sets of 3, which represent what the user is allowed to do with it, what the group is allowed to do with it, and what everybody else is allowed to do with it. And this is a pretty standard set of permissions here. User can do anything, group can read and execute, others can read and execute, but not write to that file. So we can actually change another bit, which you don't really see here. There's more bits hidden, which is the set user ID bit, which will cause it to execute as the user or group which owns that file. So if instead of an X, I see an S in that location where the X should be, then that file is going to execute with those permissions, right? If this was an S, it would actually run as root, even if I am a low-privileged user. So let me just show you what that looks like. I'm going to switch down to a low-privileged user here, and I happen to know, we'll find it here in a minute, but I happen to know that there is a file in, I think it's just in var, here we go, called bash, and as we can see, it is set user ID. The SUID bit is set. And actually the group ID, set group ID bit is set as well. So when this runs, it will run as root. Now, bash tries to protect us. If we run just var bash, it's going to keep me as the low-privileged defsec user, but it also allows me to bypass that by doing bash-p, and now, without typing password, I am executing as root, right? Because this thing was set user ID. So you really want to watch out for any executables on the system which have that bit set. A nice trick for finding those is, again, with the find command, super powerful. So we're going to say search over the whole hard drive and show me anything which is a file, i.e. not a directory or not a link, and then show me anything with the permissions. Well, this is a permission mask. I'm not going to go into how that works, but if I put -4000, this will show me anything with the set user ID bit set. So let's just see what that outputs. There's some error messages. I should have also said pipe error messages to dev null again, and we wouldn't have seen those, but luckily we got any. So there's a whole bunch on here by default. Many of these are perfectly appropriate to be set user ID. So things like password, user bin password. That has to be set user ID because in order for a normal user to change their password, i.e. edit their password hash within the system configuration, they have to be root to do that, right? So there are some things that just need to be set user ID. Sudo, In fact, ping on many systems is set user ID because of the type of socket that it has to set up. So just because something is set user ID is not necessarily problematic, but let's go back to this slide, no good, find evil, right? Many of these things are perfectly fine. This one is not known good. So if you know what this looks like on a standard Ubuntu system, that's going to jump out at you as something, right? So in order to fix this, pretty easy, there's my bash file that's set user ID. I can either remove the set user ID bit by saying chmod -s and then the file name. Now it should not be set user ID. So this. So now it's gone. Now it will just execute as whoever runs it. Or it might just be a good idea to delete that, right? If I'm a defender and I see a file called bash in var, I'm probably just going to go ahead and get rid of it. That's probably not. But I don't know. Use your good judgment. Okay, moving on. File ownership and permissions. For you to be effective here, you really need to know what good data looks like. That golden rule really comes into play. So I'm going to give you some general rules because there are too many things to enumerate one by one. Oops, that's not what I wanted. No, how do I make that go away? There we go. That's what I wanted. So in general, here are some rules to follow. Files owned by root should probably not be writable by anyone who is not root. So by default, everything that the system depends on is probably going to be root, right? So I just ran ls on the etc directory. Almost everything in here is going to be root, minus a few other things. It's perfectly acceptable for root to be able to write to those things, but if I looked through this folder and I saw a write bit on anyone else, that's not a link, links show up as writable by everyone, that's going to be a sure sign that there's a problem. Particularly sensitive. So for instance, the shadow file, which contains all of my password hashes for my users, if I saw a write bit there, that's a sure sign that we have a problem. So in general, if a file is owned by root, it should not be writable by everyone else. Also in general, files in etc should not be writable by anyone except root under just about any circumstances. So this is all of your system configuration files, everything that controls how your services run and how your users and groups are set up, and these should only be writable by the root user. Sensitive files also should not be readable by just anybody. Everything in etc can probably be considered somewhat sensitive, although by default many are readable by normal users. So sudo is one that is not. We can see that that read bit is not set for the sudoers file, so a normal user should not be able to see what's in there. Shadow definitely falls into that category, right? This is a sensitive file. It should not be readable by anyone. But we can have a philosophical debate over if things like maybe your SSH config, that folder is at least enumerable by other users. You know what? I actually don't know here. We're going to go off script and let's see if we can read that as a normal user. So if I look in etc SSH, it looks like I, as a normal user, can actually read those configuration files. So if you wanted to harden your system and make it a little bit more difficult for somebody with low privileges to become someone with high privileges, then removing these read bits from somewhat sensitive files might not be a bad idea, right?
We had some questions from chat. The first one is,
Sure.
What is etc shadow?
Yeah, good question. So let's just look at it. I trust that you won't be able to crack all of my password hashes in the during the course of the stream here. I'm going to delete the box later anyway. So shadow contains your password hashes. We'll look at this one in a minute. That looks suspicious. But if a user account has a star here, the account is locked. It doesn't have a password. if the account has a hash visible, so this is a password hash, that is what's used to authenticate me, right? If I look in Etsy password, which is sort of like the sister file to Etsy Shadow, this has a list of all of my accounts and their user IDs and group IDs, home directories, and shells, right? So password and Shadow sort of work together in combination. This is all of the information about users which should be publicly known by people on the system. Shadow is information about the users which should not be. Right?
All right, cool. The other two questions were, can hackers take advantage of SUID executables? How do we defend against that? And can SUID executables be used for honeypot?
Yes. So let's see. That's 3 questions. So can a bad person use a set user ID executable? Yes, in 2 different ways. The first way is if it's an old version of the set user ID program, there could be vulnerabilities which would allow them to escalate. So, for instance, user bin cron tab. This is a program which, well, that one's just set group ID. That was another one. Password sudo, right? Sudo is set user ID. Not too long ago, there was a vulnerability discovered in sudo which would allow you to take control of the program as it's executing, right? A flaw in the program that you could exploit. And since the program is already executing as root, you then gain the root permissions. So understanding historical vulnerabilities in the default set user ID programs is also a good idea. Check what versions they are. If you're running old versions, try to update. The other way that an attacker might abuse a set user ID binary is by making one themselves, right, as a persistence mechanism as opposed to a initial access mechanism. So watch out for exploits against existing ones, but also watch out for new ones being created as a persistence mechanism. And then there was a third part to that question that I forgot already.
Someone wants to know if honeypots can be used as an effective honeypot strategy.
That's an interesting idea. So in the context, so in general, yes. In the context of set user ID programs, I don't think that I would leave anything set user ID lying around on your system, even if you think it is a safe honeypot. Like, if you write a program that's going to disconnect the user and log the attempt, and then you make it set user ID hoping that they'll run it, there's, I would say, an equal chance that you will make a mistake which they will see and be able to exploit it than there is that you'll catch them at all, right? So I would not recommend just creating set user ID binaries if that's what you're getting at. But yeah, I think in general, honeypots are a useful trick. Any other questions there, Shane?
Nope, that's it. Thank you.
Yeah, all right. So moving along here, files outside of user bin, userlib, and lib should probably not be executable. Again, with some exceptions, right? So all of your binaries that you're going to run on the system are probably either going to be in /bin, /userbin, or there should be libraries in /lib and /userlib. So I can list all of those things. And anything in these folders, it's fine for it to be executable. If I am looking in my, let's say, temp directory, and I see something that is executable in here, that's a sure sign that something bad is going on. I can't think of very many real situations in which a file needs to execute out of the temp directory. I don't know, maybe there's a piece of software that drops a script in there, and it could happen, right? There are exceptions, but things in temp should not be executable. Fun fact, if you want to harden a Linux system, you can actually set up temp on a separate partition and mount that partition with a no execute flag, which will deny execute permission categorically from anything in the temp directory. So that's a fun trick. But also, you know, if I was looking through my, let's say, var www directory, which is HTML, which is where all of my web stuff is. If I see files executable in there, that's probably a bad sign. So in general, watch out for executable files outside of those places. Also, anything that is owned by a standard user should probably not exist outside of home or temp. So if I am the DefSec user, just a standard user on the system, the only places that I should really be able to write files, with a few exceptions, are in my own home directory here or in /temp. Those are meant for me. I guess there's also like /dev/shm shared memory. There's also var temp, which is sometimes linked to just standard temp. There's a few other places, but if I'm looking at my Linux machine here and I just glance at the root of the file system and I see something owned by the user John Smith in the root, that's a bad thing. Or if something is owned by John Smith in the /user directory, var or etc. Anything owned by a normal user should be isolated to those directories. So there are two tools that are helpful in fixing those file permissions. The first one is chown, which changes the ownership of a file. The syntax here is a username and then a group name. So if I wanted to make a file be owned by the DefSec user and the DefSec group, I would do that. And then I would change the file name by giving it a path there, right? So this would change temp derp to be owned by DefSec. Also, I can use chmod, which we learned earlier, is for changing the permissions of a file. And useful trick here, you can type U or G or O or any combination of those things to mean user, group, or others. Then after that, you can put either a plus or a minus to add or remove permissions. And then after that, you can say R, W, or X, or again, some combination of those, and give it a path to a file. So this here would say add, read, write, and execute permission for the user, group, and others, everybody else, for this file. So if my file was, let's say, readable by the others triad, and it shouldn't be, I could say chmod O-R temp derp, and that will remove the read permission from others, right? So if you log into your machine and you find that etc shadow, this file right here, is readable by everyone, that would be to fix it, right?
So 2 questions. One person wants to know, should they be worried about exposing, presumably, executables in /sbin, like ifconfig? And someone else wants to know, what is the inheritance of file permissions like?
Good questions. So this is an oversight on my part. I these in and then forgot that, yeah, correct, sbin also has binaries in it. Sbin is binaries that usually only need to be run by the root user. So you have things for like modifying your disk partitions. You have things for changing the Ethernet tables that apply to your network card. Anything dealing with your hardware system is in sbin, and there is also a corresponding user sbin, at least there should be, which contains more stuff. So that was just an oversight on my part. That sbin should be included there. But again, exceptions exist, right? So there's even more outside of that. And then the second part of that question, Shane, remind me again?
Inheritance of file permissions. So like probably sticky bits or like just created by a certain user.
Right. So, okay. So if, let's see, let me switch to the DefSec user. If I look in /, I can see there is a /root directory. This is root's home directory. By default, the only person that can do anything with that directory is the user, the group, and everyone else can do nothing. If I, as root, created a file in here and did chmod 777, basically give it all permissions, I would still not be able to access it as the DefSec user. At least I think. I should probably verify that. I'm just going off memory here, and I might be wrong. But I think I would not be able to access that as the DefSec user, since the higher level directory that it's in doesn't give me permission to read, I believe. Yeah, so Shane also mentioned sticky bit. That's a whole topic on its own, but oftentimes, we can see right here, the temp directory has the sticky bit set, and that changes how you are allowed to interact with files in the directory if they are owned by other users. Let me think about this. So if I have write permission to the directory, then by default I should be able to delete files within that directory. But with the sticky bit set, if they are owned by somebody else, I believe then I would not be able to access them or delete them. I think. I'm only about 80% sure I told you there, so maybe Google those things as well. But those are excellent questions. Apparently I have some packages available in the system. Okay, so let's talk about cron jobs. Cron is a daemon that runs on almost all Linux machines, which runs scheduled tasks. So think of this like scheduled tasks on Windows. It can run to a granularity down to 1 minute, or any larger increment thereof. So this is a great persistence mechanism for red teams if they're trying to break in and have something run regularly, and call back, like a shell that's going to call back every or something. There are a few different places that cron jobs, as they're called, can be set. So a cron job is something that will happen periodically. The first is the system-wide cron tab in /etc/cron tab. So let me become root again, and let's look at etc cron tab. So the way this is set up is each cron job has 5 fields for the minute it runs, the hour it runs, the day of the month, and the day of the week. Then just in this file, not in the others, we have a user that the command will run as, and then the command. So I set one up here. This is non-default. These things here are default. This one is non-default. So this says run every minute, every hour of every day of every month of every day of the week. So essentially once every 60 seconds. This runs as root, and it will echo the word ASDF to temp text. So if I go look at temp directory, there's a file called temp text, right? And if I look inside it, there's the ASDF. So that was created by the cron daemon. So if I've just broken into a Linux system, and this is CCDC, so I'm trying to hack everything and persist as quickly as I possibly can. Although this is not terribly sneaky, I could just drop a line in the cron tab, and that will run every minute. I will tell you as a red teamer, a common trick that I use to try and hide these things is I just do this. Perfect. Look, now I have an empty cron tab. There's nothing there, right? Or maybe I do this. I think that would still work. I think that would be okay. So make sure, I don't know, maybe don't just open it as a standard editor. Maybe you want to cat it out. Cron tab, and now it's very obvious there's the bad thing. That looks quite suspicious, right? So another place that these cron jobs can exist is in many directories prefixed with cron.something in Etsy. So let's look in Etsy cron. I think this will work. Yeah, that shows me all of them. So there is a folder called cron.d. There's a folder called cron.daily, .hourly, monthly, and weekly. And scripts in these directories will run on that frequency. This one is configuration stuff. So for instance, if I wanted my shell to call back every hour, I could drop a script called something innocuous, something that looks okay, here in cron.hourly, and it's going to run every hour, right? Or I could edit a script that already exists in this directory and add some other piece of malicious code. So from a persistence standpoint, you want to pay really close attention to these directories. Alternatively, if they're not being used for anything, which think carefully about, because there's some clearly important things here as well. You don't just want to nuke all of these. But if you have to, if you edit the cron tab and you simply comment out these 4 lines, that is how all of those directories get run at all. So I think commenting those out should stop everything in those directories from being run. But do so carefully, right? Caveat emptor. There are also per user cron tabs in var spool cron /cron tabs. So if I look in that directory, var spool cron tabs, I see that there is a file owned by the defsec user called defsec. Let me make another one here. If I run cron tab -e to edit my per user cron tab, and then because I'm a noob, I say 1 nano. That's a joke. Nano's for pros too. I'm a noob, but if you're a pro, you can still use nano. And then I could say, like, I don't know, every minute, run ID, right? Run a command. Now, if I look in that directory again, now there's one for root as well. So watch out in this directory. If somebody breaks into your low privileged user account, they don't actually have to edit this file or anything in those directories. They can simply run cron tab -e and they can have something run as that user every so often. So watch out for bad things there. The fix for this, I mean, simply delete them, right? If you see a bad cron job in there, delete it. Or alternatively, you could try and disable the cron service. So I think you could say service. No, how would you do this? The old, let's see, I haven't done this in so long. I think you would do update rc.d disable. Is that right? Oh my God, how embarrassing. Cron disable. There we go. Now cron's disabled. That's the old way though. The new style, if you're on a system D machine, is system control disable. Right? So if you're not using the cron daemon, might be a good idea just to remove it, but that could also be useful to you as a defender if you want to run periodic jobs. So think carefully. So any more on machines with system D installed, which is everything from the last 4 or 5 years onward, we have switched over to something called system control timers, which attempt to solve the same problem that cron did, just in a different way, in a better way. I have not really seen these used much by red teams at CCDC or in real life, but I think it's coming. This is coming soon. So if you run, I'll let you mostly Google about these on your own, but if you do system control list timers --all, we'll see that there are a few jobs which are configured to run periodically by system D. Those are all stored in either etc systemd system, and then they would have a timer prefix, but I don't think there are any in there. Or alternatively, they might be listed in /user /lib and then the rest. Nope, just kidding. I got that wrong. What did I do here? There should have been some. Clearly I did something wrong. User, lib, systemd, system. Okay, I've done something wrong. Now I'm going to have to fumble around and find the right answer, or we're just going to move on and I'll trust it. Let's see, there should be links here. Lib systemd. Maybe that's it. Let's look in there. Yeah, there's all the stuff, right? So star.timer, and there's my timers, right? So my slides aren't exactly accurate. Idea. Probably the quickest ways to get rid of these are to system control stop them, or system control disable them, or simply just delete the file, but make sure that you reboot if you just delete it, because it could still be running things might still run.
Someone
So
wanted to point out for the last slide that when you disable cron, it's still running until you reboot. So you should systemctl stop it as well.
excellent point. Very good point. So if you're trying to get rid of the service, yeah, great point. And actually, this goes for any daemon, right? If you disable or delete the service, the binary might still be running in memory. Got some funny stories about that we can maybe tell on another time, but yeah, watch out for things running. So services. In the old days, service daemons running in the background with service -- status all, and that still works on modern like Debian and Ubuntu systems through it's basically using systemd in the behind the scenes, but they still provide this command. And so we can see everything that's running. Again, back to my first slide, find evil, right? You should know kind of what runs by default. And if you see something in here called logs job or something, that's going to look suspicious. Anymore, you probably want to use system control and say list units -t for type service, and you can add state equals running on the end to see what is currently active. But you might not want to do that, right? If it's something that has been stopped but is still sitting there and still might come back to life later, you might want to look at the others as well. But we can see, oh, interesting. I thought that I guess I disabled it, but I didn't stop the cron. So it still thinks it's running. Or I'm not 100% sure what's going on with that. Okay, so you can disable services with system control disable or mask them. So masking them basically means that this may be more than we want to explain now. All of the services by default are stored in lib systemd system, right? But if I want to tell the system that it doesn't exist, I can write a symlink with the same name linked to dev null in etc systemd system, and that will cause the system to basically forget about it. So you can do that by typing system control mask and then giving it a name. I think I should be able to do that, right? And now it has symlinked etc systemd system cron.service to null, and the system should not run that. So users and passwords. Reiterate, good find evil. You should look through what is commonly found in a default password and shadow file and try to understand when something looks off here. So some things that might look off. Non-standard users. We have one here called defsec. Its ID is 1000, and other users would have IDs incrementing from there. So anything that's not one of these standard user accounts might be suspicious. And the order doesn't matter, right? I could have this defsec user up here hiding in the middle of all of these and it would still work. And it could have any user ID, right? So I could slot it in here at user ID 35, and that would be perfectly fine. So familiarize yourself with what accounts should exist on a system and what accounts should not. From there, familiarize yourself with what shell they should have. So most of these have user sbin no login, which will prevent somebody from like SSHing into that account, utilizing that account. Sometimes you'll see bin false, but if you see mostly no login or mostly false, and then somebody has a bash shell, that's going to be suspicious, right? In general, the only users that should have actual shell, like bash or sh, should be root, and then any of your real human user accounts, right? All of these should probably not have a shell. In CCDC, a common thing for the team setting up the environment to do would be to just give them all shells, and you might want to remove those starts. Also, watch out for, I'm going to skip one here, users with user ID 0. The only account that should ever have a user ID of 0 is root. Nobody else should have that. So for the games user here, to have user ID 0 is very, very bad. That's not good. So watch out for that. Yeah. So also watch out for daemon users with passwords in Etsy Shadow. So if we look at the Shadow file, bring all my hashes up here on the screen again. Probably the only users that should even have passwords are root and then your standard human user accounts. If anything in between, if any of us have a password set, like the games user, that's a pretty sure sign that something bad is going on. When I'm doing red teaming for these competitions, I often like to set the daemon user to user ID 0 and then a password. And it's easy to miss because its default user ID is 1. But you would see that if you look at the shadow file, right? So a couple of useful commands for fixing those things. The user mod utility can change user attributes. -L will lock out a user account. So let's say I just found that the games user is doing something naughty. I'm going to lock that account. And now when I look in the shadow file, I should see, well, I was hoping to see a star there. Maybe I misunderstand how that works. All right, somebody help me quick. Shane, rescue me. What did I do wrong?
It puts an exclamation mark in front of it, so the hash is invalid.
Oh, that makes sense. Okay. My apologies. Thank you, Shane. You're the best. So it puts not a star, but an exclamation point in front of the hash. That makes it good. So I can also use user, and this should actually be user delete, not user mod, -rf, and give it a name, and it will delete that account. This, I think, also removes the home directory and then forces them to log out if they are still logged in. So user delete -rf is so something else that you might want to, you are competing in CCDC and you sit down at your machine and you have 1,000 user accounts and they all have a terrible default password, is write a quick script to change those passwords. So I have a for loop in Bash here, for you in, and then this is a sub shell, which is running another command. So let me just run that piece of a command and let's see what we're doing. Let's piece this apart. So I'm going to cat Etsy password. That's the first part of it. That prints out all of the accounts. And then if I pipe that to cut, and I split it on a single colon and show me the first line, I see all of the user accounts. And something else that I don't have here on my slide, but might be a good idea, is to also say grep-v root so that we don't change root's account. Notice how it skipped the root account now. And feel free to modify this in whatever way is useful to you. Maybe you want to say in1 to only the last line, or if you have 10 users, maybe you want 10 lines. Feel free to modify that. So we're looping over all of those usernames, and then for each one, we are echoing username, colon, and then a password to the chpassword, change password utility, which if we just run in isolation here, so we'll do echo like defsec, colon, I probably shouldn't do this because then you're all going to log into my machine here on the live stream. If I echoed that to change password, that should change the defsec user's password. You can also do this in batch. So batch, not bash, right? If I have a file full of username password combinations, I can just do chpassword and get in from that file containing all of these combinations, and it should change all of those for me. Use with caution. You could lock yourself out if you miss that route. I'll pause for a moment. Any questions, Shane?
None that I see. Well, The Nord asks, if you wanted a dumb defense, could you just continuously change passwords for all accounts?
Yes, you certainly could. Could you have a cron job that rotates every minute? By all means, go ahead. In a competition or in a real world, you need to be aware that people or scoreboards or somebody's going to be logging into those and using them. So it may not be advisable to constantly be rotating them automatically. But yeah, I mean, that's certainly an interesting strategy, and it would work. All right, so I know we're at 50 minutes. We got 2 slides left, and I think we can do this quickly. Firewalling. Up until just the past year or so, IP tables has been the standard for firewalling on Linux machines. Recently, there's been a push to switch to something new called NF tables, and there are some new tools for managing those NF tables. So this may not be relevant for many years to come, but for now, any Linux machine built in the last decade probably allows you to use IP tables to manage firewalls. This is also a whole talk on its own. Easily talk for 2 hours about IP tables, but here are the points that I want to get across. Number one, it is better to have a default deny firewall and then allow selectively than it is to have a default allow and deny select. And so that's just a good piece of security advice in general. Your default should fail closed, fail safe, and then you should allow only the things that you know are good. Also, egress filtering is a really, really good idea. Missed. So when you think about firewalling, oftentimes we think about blocking incoming traffic, and that's good. We do want to block incoming traffic that we want to see. But if somebody lands a shell on our machine, we also might be able to thwart them from abusing it if we can block the outbound traffic from that shell. And this is actually a really effective defense technique, which defenders oftentimes forget. So be sure that not only are you blocking it, but you are blocking outbound traffic that you don't need also. So you need to do a little bit of planning and thinking ahead of time. I would not just roll into a CCDC competition and drop all network traffic and start trying to figure it out. I would try to understand the network first. But once you understand what traffic needs to be coming in and what needs to be going out, the first thing that you want to do is set your default policy to drop. If you're SSH'd into the machine as I am, do this cautiously, because if you set the default policy to drop without an inbound allow rule for that SSH connection, then you're going to lock yourself out. But if you're doing it from a console, no problem. So I'm not actually going to hit enter here because I'll lock myself out. But if I run iptables-l, this will show me all of the default rules. So by default, everything is set to accept, and there are no rules. I would probably write a script that sets my default policy for input to drop. I'm not going to hit enter. And my default policy for output to drop. And sometimes you'll also see policy for forwarding to drop, but that one's less important. And then once I have my default policy to drop, then I can add in all the things that I need to talk. So I would say like iptables append to my input chain, protocol TCP destination port 80 for my web server -j accept, just as an example. So what I've said here is for any traffic going into the machine input, if its protocol is TCP and it's headed for port 80, then I would like to accept that. Or maybe if it is protocol UDP and this is outbound traffic and it is headed for port 53, that's probably DNS, and maybe I want to allow that, right? So again, this could be a whole talk on its own. This is another 2 hours easily, so I'm not going to go through all the amazing things that you can do with IP tables, but it sounds like maybe you're going to have a talk on that soon. So learn some IP tables. And the last thing that we're going to glance at here is logs. The var logs directory. Got to type the whole thing because there's something else starts with LO there. This has all of your service logs and system logs. And this is a great way to try and figure out how somebody's gaining access or what attempts they're making at access. One of the most useful is var log auth.log. Let's just take a look at it. So in auth.log, we're going to see authentication, both attempts and successful authentication from end user. And look at this. I'm already seeing authentication attempts from just random IPs on the internet, right? Because I spun up a SSH server, there are people all over the place trying to log into it. And they tried to log in as root. There is no user called admin. Somebody attempted it, right? So this is like happening live. I set this server up, what, an hour ago, maybe? So failed passwords are, maybe it's important to look at those because you can see what somebody's trying to do. But if a password works, you should see the word accepted. And so I see 2 times, oh no, I leaked my public IP address. Oh well, that's okay. I see 2 places where a public key was accepted for this user from this place, right? So it may not be so concerning to me when a password doesn't work, but I really want to keep track of when a password does work, or a key for that matter. Cron jobs are also listed here as well, so I can see when the cron daemon ran. Show there. There are also logs. So, for instance, I have Apache, the web server running on this machine. There is a var log Apache 2 folder that has an access log and an error log. Let's see if anyone's trying to access my web server. Sure, there's a whole bunch of things. Somebody's been accessing the web server. Error logs are available there too. If I have like a Samba SMB server, that's a directory, not a file. I can see there are logs for all of these people as well. That's interesting. This is how many attacks I've gotten from the public internet in 1 hour of my server. I look forward to turning this server off. Yeah, so poke through those logs. That'll be useful to you. If anybody is messing with kernel modules, that would probably be listed in kern.log. That's, I don't know, maybe more like hardware-specific information. Let's take a look at that. Var log kern.log. So we can see things happening with disk or when somebody else needs to root. That should be. Okay, the last trick that I'll leave you with here, this is one that this trick. If you use tail-f, it will automatically update that log as things are happening. So I'm going to tail-f var log Apache 2 access log. So I'm just watching it. And then let's open a browser here. And let's go to defsec. What was this? hostbin.org/yo. And there we go. Live in real time, I see yo show up. If anybody's watching this, feel free to go to a URL. Let's see if it shows up quick. And I'll pause there. And yep, there they come. Here comes more people. What's up? There's somebody else in the live stream. So I'm going to kill that before everybody starts typing profanity to my web server, but that's a handy trick for watching log files if you have the time. Okay, and that's the last slide there. So I will pause. I'll stop there and take any questions if anyone has them.
One person asks, how do people find your server on the internet?
They are scanning all of the public IP space. So an IP address is made up of 4 numbers from 0 to 255, and there are 4 of them, right? A.B.C.D. If you run the math, 256, there's 256 possibilities for each of these is about 4.2 billion possibilities. That's a lot of IP addresses, but not that many for a computer to just sit and scroll through for eternity, right? So people are just scanning the entire internet looking for vulnerabilities, and that's how many people were looking at my server just in the last hour, scanning the public internet. Where was that? Probably scrolled off. Okay, yeah, it's way gone, but they're just scanning the public internet. Other questions?
All right. Thank you, Andrew. This was a great presentation.
Perfect. That's perfect. That's exactly 1 hour. So we'll stop there and email me if you have any questions, and have a great evening.